Okay, so hey, Thomas, I think he's joined us. Just want to check and make sure, is there any other comments about the opulent voice work for the week before we talk about Eve? Thomas, if you're ready, happy to turn the floor over to you to talk about what's happened over the past week.
Hey, hello, good evening. Sorry, I'm a bit late, but due to the difference in daylight savings, this is a bit inconvenient. But yeah, we had some success this weekend. So I didn't have a time to put a really cohesive presentation together. So I have a few photos and a few graphs, and I talk to that. But ask questions if there's anything more you want to know. Okay, so this is a slide that I think I've shown before, but now I replaced the moon by Venus. But this was the setup. We basically in Dwingelo had a B210 that we used to transmit and to receive, and in Stockard we had a B210 just for the receive. It's really nice to have two of the same SDRs, because anything that you always have DSP delays and other things, they are common to the two sides. So all your timing is good. So we have, as I've shown before, practiced this on the moon, and that actually has paid off very well, because especially the Doppler calculations need to be extremely accurate, and you need to separate uplink from downlink if you want to be within the accuracy that we need. And we could tune that all on the moon, and that actually gave us the opportunity that during the Venus bounce, we could already analyze the signals, because we had a whole crowd watching us. So everybody was very anxious to know, well, did you see anything within 5 minutes, of course? And we could. That was the nice thing. So Dwingelo normally does not have the capability to transmit with 1,000 watts, also because we're not legally allowed to do that. So for this event, we had a special permit to do 1,000 watts, only for 2 hours, but that was more of an administrative mistake. So we borrowed a 1 kilowatt transmitter, and we had to interface that to our own systems, which in the end was not that hard. The original plan was to have it basically downstairs, so we would have a cable to the front end. I was not in favor of installing it in the front end, because it's 1,000 watts and it's complicated and things can burn and it can get out of hand. But some other people thought it was a good idea, and they were right in the end. It was really simple to do, and we put it in the front end and it fitted. So in the end, we really had about 1 kilowatt on the horn, which definitely made a difference. So here, I have a few non-technical slides as well. Here we're actually, what you see on the back here, so you see this box, that's where where the feed horn is and some of the LNAs. And here at the back, you see actually the 1 kilowatt transmitter that we borrowed. And it was pure luck that there was a bit of space here in the back. And here you see how you call that, the box where the feed fits in, and you see a rail here, and if we put the lift a little bit higher, we can actually extend the rail from the lift into the feed box, and we basically drive the car into its position. So here we are, this is the Friday. Here we're basically installing the amplifier in the front end. And this picture here, we're actually on source. So we're pointing to Venus, and we're waiting for the 12 o'clock UTC to get started. This is a nice picture one of the other people made. Here you see very clearly how close we were to the sun. So this is pointing at Venus. But you see that we're actually just a few degrees off the sun, which probably also affected the noise figure of both our dish and Stockard. But that's, we had measured it before, but it's hard to make it to do it very accurately, because it changes all the time based on the exact position. Okay, so this is during the transmit. I actually looked at the time of the picture. This was made by somebody else, and 13:01, so that's 12 o'clock UTC. 7 seconds after 1 minute past 12. That was the first transmit. That's probably why we're all laughing, because it seems to be working. You see actually the CW going out on the monitor, and you see the small meter here that has its power completely to the maximum. So here everything was still working, which it did for a while, but this was basically the start. So we had a few people watching. There were actually many more. Interesting here is that two of the people here are from basically it's our equivalent of the FCC. So the people that gave the permit actually came to watch. I'm not completely sure if they were just for the fun there or completely in function. But anyhow, they were very supportive also to actually process our application in a time frame that they normally would not do so. We are very happy with how they supported us. But before I get to the results, as you probably have seen, the bad news is that after 10 uplinks, our PA broke down. We still had a 2-hour window. So we immediately took the lift out and tried to get the amplifier down to see if there was anything we could repair. There was nothing obvious, and we thought at that moment that it was still a power connection. So we fixed that and inserted it back into the front end. But when we powered it again, the power was still not good enough. So we were only getting 300, 400 watts, which indicated that something was wrong. And then we decided it was too dangerous to proceed without knowing what was happening. A few days later, when opening the amplifier, indeed, some of the transistors were simply burned. So I think we pushed a little too hard. So having the box up there with no ventilation, it probably heated up too much. And we're still lucky that we got 4 times a CW transmitted. It's really unfortunate that all the nice waveforms we had ready and which were all automated, so like the Zadov Juice and the BPSKs, none of them got transmitted. So that's the sad part of this whole story. But still, the important thing, even on the first CW, we could already see something. What you see here is the final analysis. And even today, I managed to improve the results even further. So we had 4 transmissions of 278 seconds of CCW, because the round trip time was 280 seconds. So we wanted to be sure to capture everything, which were both received in Dwingelo and in Stockert. And here are the results of Dwingelo and Stockert separately and together, averaged over the 4 transmissions. So this is all the data we have basically in one graph. The interesting things here is that, both telescopes would receive it with a significant peak. The 4 sigma was actually something we decided on before the experiment. It's always good to actually set your threshold before you start, because otherwise you start just looking for peaks and then say, well, that's significant enough. So set your threshold before the experiment, not after. And we clearly went over that. I'm quite surprised about how much better Stockert received us than we did ourselves. That's definitely something to look into, where the difference comes from. We know both telescopes quite well, and they're quite well characterized. So this is a very good comparison. Again, we have done other comparisons on the power from Cygnus A and other experiments. So this feeds into that. And the combination, of course, gives you an even higher signal to noise ratio. So this is extremely nice, and we're extremely happy with it. Of course, it's only CW, so there's no distance or any fancy things. Given the peaks that we see here, the Zadov Juice would definitely have give something interesting back, but yeah, it didn't happen. The other thing that worked out really well, as you can see, is the Doppler prediction, because it's exactly at the 0 bin, and I have a better graph about that later on. Which was, I think, the tricky part of this, because especially on the Doppler rate, even a millihertz wrong and you won't see any peaks anymore. So yeah, this is basically the main result. Of course, the next step now is to see how we interpret this and feed this back into the link budget. Um, uh, First, I thought the returns were weaker than I expected, but now I reprocess them. I think they're stronger than I expected. So yeah, we have to combine all of this and refine the link budget. At least we have two data points now from Stockert and from Dwingelo. So this is the same graph, but now expressed in dBs. The other one was linear, which basically shows that you have a carrier to noise ratio of around 2 dB. Well, it's actually the signal to signal plus noise ratio. Do I say that correctly? No, it's the signal plus noise to the noise ratio that you see here of 2 dB, which actually is quite high. This is the combination, higher than I expected. The other thing is that if I zoom into this, I would have hoped to see something of a distribution here, but as we already expected, the spread was relatively low. So even let's say the 2 Hertz offsets are already within 1 standard deviation. So yeah, that doesn't mean anything anymore. So I don't think we can conclude anything from this, except that a lot of power was luckily in the 1 dB bin. Then this is a really interesting graph that's made by our colleague Kees Bassa. This basically shows again the same peak as the one you see here. That should be roughly the same graph as you saw before. But here you see the variation if we change the Doppler and if we change the Doppler rate. So it actually shows how good our prediction is in both the Doppler and the derivative of the Doppler. And that actually shows to be extremely accurate. And this is also a very good double check if the signal you're seeing is real and not something that is coincidence or something, or is created by some other artifact of your processing. This is also how we analyzed fast radio bursts and pulsars, for example. But I really like this because it shows that the prediction was spot on, and that there are no other significant peaks in the same area. I think, yeah, that's basically what I quickly put together. There's a lot more work to do, I think, and it's going to be really interesting to match this to the link budget, and it will hopefully help us to refine it a little bit. So unfortunately, from the DSAS side, we did look at the data, of course, the data that was received by Stockert, but 3 minutes was really not enough. Even if there would have been something there, 3 minutes is a little bit too less to actually integrate and get a significant response. So yeah, very unfortunate. It could have worked. I mean, the amplifier did it for 3 minutes on the US side, but unfortunately not more than that. Okay, well, that's basically what I had put together for today.
Thank you so much. This is quite the achievement, and we are, on behalf of the ORI board and all of our members in our community, we would like to thank you and Dwingelo and Stockert for including us in this effort. We had a very small part in modeling, but this is very exciting, and we are very much looking forward to the next opportunity, or the next best opportunity, in October of 2026. If there's any sort of opportunities over the next couple of weeks while Venus is fairly close, then we'll do whatever we can to help make that happen. But we'll take what what we've learned already, and what you've summarized is amazing. And yes, there's a whole lot of work to be done still on what has been learned over the past weekend. This will take a while to weigh and consider and incorporate, but we're in it for the long haul, and we're here to help with link budgets and any sort of modeling or proposals for various communications solutions. We've been putting in a lot of effort on both the Zadov-Chu sequences and also the OTFS approach, orthogonal time
Yep.
OTFS is a sort of a variant or a different view of OFDM. So it's a delay Doppler channel, and we think that equalizing that channel may give us some additional gain and be a way to go from radar detection, which is what has been done here, clearly done here with excellent results. But the basically a radar bounce. We want to move from doing a radar bounce to doing some communications to actually be able to prove that we can bounce information off of Venus. And this is a very tough thing. Moving from just a bounce, an echo, so to speak, to being able to hear words. If you want to look at it as sort of a audible, um, you know, example or analogy, and that's a big step up. So we're all on board, and thank you very much to Thomas and to Wolfgang and to everybody that's been so congenial and helpful and communicative. This is a big deal, and we're very much looking forward to all of the articles and papers and advancements that will come from this work. Very,
Yeah,
very.
well, the good thing is we have time now. So the time pressure we were under is gone. We have 1.5 years. So,
Yes.
and the other thing, and it's unfortunate Pete is not here because I think he's making really nice progress on some of his ideas. Is that we can actually practice some of these things on the moon, especially now between Dwingelo and Stockard. We have a setup where we can easily do that, and of course the moon is much easier. But we can reduce the power. One of the things I want to try, and maybe this is a good trial also for making a communications protocol, is to take all the amplifiers out. So we simply put the B210 directly on the feed, and that's it. And do a moon bounce with that. Then we're back into the Venus budget. And we have plenty of time for that. No hurry, but yeah, it would be nice to continue this cooperation.
Yeah, well said. The time pressure of a very small window. This is just like almost like competitive sports where you're at the Olympics and you have like one chance to do that triple jump and that's it. So, or gymnastics, one chance or two chances to do that vault. So yeah, now we do have a lot of time to really kind of take what we've learned and develop some and to practice. The moon is not like a perfect replacement for Venus, but it's really, really close. And the EME community has learned about this, and I think that they'd be very receptive to lots of experiments and to use and to practice what we're talking about to get ready. So I'm very much looking forward to this. Oh, go ahead, Daniel.
Yes, question for Thomas. Thomas, can you hear me?
Yeah, sure.
Great. What is considered the reflecting layer on Venus? What part of Venus is actually doing the reflecting?
As far as I know, but that's from all the 60s and 70 papers, it's the surface, because if you actually put enough power on it, you can make a map of the surface of Venus. So it must be the surface that is reflecting.
And are you reflecting from the daylight side or the nighttime side? I'm imagining it's the nighttime side.
It must be the nighttime side at this moment. Yes, correct.
Okay.
Yeah.
Okay.
I assume, yeah. It's anyhow hard to see Venus when it's next to the sun at an 8-degree separation. We actually wanted to have an optical telescope as well, but we didn't succeed in getting that together.
It's possible to see Venus in the day?
I think you can if you have the proper filters, and there's something like an alpha filter or something. I'm not an expert on that.
Yeah,
Okay, thank you.
it's possible. It's a kind of more a rare astronomical target than at nighttime. So it's obviously much easier to see it when the sun goes down. But yeah, with the right filter, you can see Venus.
You can
And
see
then the
the
last
picture if
question.
we see.
Yeah, right. It was very close to right on the sun. What is the scheduling for Venus? It seems like you have certain windows. What is driving the windows for when you want to do the Earth, Venus, Earth bounces?
Well, it's mostly the proximity. The closer we are together, because the distance in the radar equation is to the fourth power. So it's even within a few weeks, it's already much harder than it is now.
Great.
Although right now you could still do it. The other thing is that the Doppler spread is lower at that point because the
Yes.
rotation and the apparent rotation are in different directions at that point. And that apparently also helps a lot.
Huh. Very subtle. A lot of parameters to consider for the Doppler. Very interesting.
Yeah, there's at least three major factors for Doppler into the link budget. And it's interesting that the Doppler shift, like the raw Doppler shift from the different velocities from Earth and Venus as they pass through their orbits. We actually have a situation like right now with the conjunction with Venus being the closest to Earth, where Doppler shift actually becomes zero. You have passes through zero because it comes close to us and then starts, it's coming close to us and then it's here and then it starts receding away. But the rate of change of Doppler shift is the highest at that point. So it's it's a really neat thing looking at orbital mechanics. And the third thing is a Doppler spread, which comes from the fact that Venus is rotating and we're using it as a reflector. So it's not a reflector that's just stable, just sitting there like a billboard. It's actually turning, and that turns out that Doppler spread is a significant factor in digital communications protocols. So quantifying it and understanding it and figuring out what it really is versus the theory has been something that's been happened over the past couple of weeks. So yeah, this is all super exciting, and we're all trying very hard to write it down in an accessible, useful way, and to look forward. The next time that in the orbit that Earth and Venus are the closest together is October of 2026. So these situations in the orbit where are about 580 days apart or so. So, time enough to it's one of those things where you're like, oh, if we start work now, we'll be totally ready. But if you wait until then you may end up with rushing and having everything be at the last minute, and that sometimes doesn't work out well.
Thank you.
All right. Yeah. Any other questions for Thomas? I know that Pete couldn't be here, but he is on board with working on Zadov Chu, on Doppler delay channel, OTFS, all sorts of stuff. He's also trying to put together some FEC or forward error correction proposals based on the carrier to noise ratios that we're actually getting back. So this spike that you see in the graphs that Thomas shared, giving you an indication of the carrier to noise ratio, that's super important for us. So with that, it's like a peg in the sand, and you can say, okay, we know this, therefore we can make some decisions about error correction. And error correction will give us some additional gain. It'll give us some additional traction. But we can't really pick a good forward error correction until we know really good results from the channel. So this is all fantastic information, and we'll know we now know a lot more, and we'll be able to fold that in as well. So when Thomas says, like, it looks like some of the Zadov Chu sequences would have worked, that's completely heartwarming because going from just raw detection of a solid echo with no information on it, going from that to recovering information is a huge step forward. And the fact that we are closer than we thought we were, from looking at the link budget, it looks pretty dire. This is all really good news. So with the time that we have into the next opportunity, I think that we can put together some really, really good work that will get us as close as possible to achieving the result that we want.
So one more thing, all the data we have collected will be open data. I just need to sort it out. It's gigabytes of incomprehensible stuff right now. But anybody who wants to play with it or work on it or get even higher sigmas out of it is welcome to do so.
Well, thank you so much. Yes, for those of you that don't know, if you're recording raw IQ data, it can fill up a hard drive in no time at all. So this is a very large data set, and yeah, we will definitely look forward. And thank you so much for publishing all of this and making it open access. That makes a huge difference. All right, any other questions for Thomas? Okay, so I'd like to go ahead and give the floor. We have a DSES board member with us, Rick, and if you'd like to speak about the experiences at DSES and tell us how things are going, what the next plans are, you have the floor.
Thank you. I have a great deal that I want to talk to Thomas about, too much for the time we have available. However, and there's a lot I don't want to talk about until I learn more, but I have been on the phone this morning to our president and others about what happened at DSES. We did not have a successful uh, uh, session in that we didn't hear ourselves. And DSES is composed of two groups of people that are very distinct from one another. And the group that led this DSES effort was ham radio operators. So they architected the whole system based on what a ham radio operator would do for EME. There are some flaws in that architecture, which bit us, unfortunately. And I'll save the details of what those were for our final report. But moving ahead, our other group of people who are interested in detecting pulsars and magnetars and such things tend to use the dish in a very different way. And that very different way is almost identical to what was going on in Europe with the B210s running the show, generating the signals, receiving the noise, recording it in standard formats and allowing for post-processing. That's what we do at DSES with the science group. We need to get our act together and redo these experiments. We own two B210s. We have all of the processing power, the computers, the multi-core computers, everything we need to do it again, this time with a different architecture. And I want to talk to Thomas about that at great length, because your suggestion that we just put a B210 up in the feed and use the moon, because that tiny little power would give us a similar kind of link margin that we can actually do some serious experiments with. I think that's fabulous. We need to keep doing that kind of work, and we need to start doing it soon so that we don't lose our momentum. And I'm willing to work on that. Unfortunately, I wasn't able to influence this because I've been buried in other work that's prevented me from influencing what happened last weekend. But I think this is a good idea, something we can do now. We have all the hardware. We need to coordinate on some firmware issues and software and recording issues, also frequencies. We were on 1296.5. Europe was on 1299.5. That didn't help. And I don't know why we could not do both. I think it had to do with our architecture again. If we only had the power amplifiers and not the transverter and the radio and all the rest of it, if we had a B210 and the power amplifiers, I think we could have done both frequencies. We need to investigate that and again, re-architect our end so we can continue experiments from now till when we're going to do this again. Very important. And we need to use those experiments to feed not only your link budget calculations, but also to do some development now on what kind of communications mechanism can we use to do actual communication of information the next time we actually see the planet. So if we use the moon at very low power during the next year and a half, we put your ideas on the air live from here to Europe and Europe to here. I don't know how often the moon is in both views, but it does happen.
Well, more often than Venus.
I think I have to get up early in the morning for that, but I can do it.
You can do it. We have faith in you, Rick.
It's so what else do I have to say? I'm a little disappointed that we only did this for one day when we have 2 weeks or so of ideal viewing. And I got quite a few reasons why that's true. None of them had to do with technology. So I'll just leave it there. The new piece of information that came out this morning from Alex about our dish deformation or something, there's no evidence of that. It's a theory. So let's not get too wrapped up in that, but I'm anxious to hear what Alex has to say about that. There are many other reasons why we might have experienced an unusual amount of power coming back into the receiver when we're transmitting, and that's only one of them. We'll see as time goes on and we continue to experiment what, if anything, we have to be concerned about. And so, yes, in any case, I'm hoping we can set up new experiments with the moon and low power and communication mechanisms and the other thing is we have a substantial not huge, but a substantial amount of money left in our budget for continuing this experiment. So if we need to do something serious, we have a modest budget to do that with. So we could afford things like more B210s, but we don't need those. We need to figure out what it is we actually need to do and execute a plan in conjunction with our partners in Europe. That's it for now.
Well, that's a lot. Thank you so much. I think you've covered a huge amount of topics there. So thank you for the clarification on the comment from Alex. For those of you following along, when you actually do attempt something like this and you're running real power in a sort of a different way, it looked like maybe the surface roughness at DSES might not be what we assumed. And so I put in an inquiry about that. So it may not be the flag that it appears to be, but we'll track it down and we'll get some good results. I think that'll
find a way to measure it somehow.
Yes, yeah, we'll measure it. So what we call of RMS surface roughness feeds directly into the calculation for system noise temperature, which is very critical for figuring out things in your link budget. So we can either just measure it, measure the system noise temperature at DSES, or what we really like to do is have a measured system noise temperature that also matches with the calculations so that we can get everything aligned. And we're getting there. Experiments like this move us forward quickly. So
I'm wondering if I could use a device like this to measure it.
Yes.
This a green laser measuring device, and it comes in two variations. One is indoor and one is outdoor. This is the indoor one. I need to go get the outdoor one because it's calibrated for longer distances.
Yeah,
But these are remarkably accurate.
great.
And I don't really know how professionals do it. So that's one of the questions I have. I have confirmed now that I'm flying up to Haystack Observatory for the first full week of May. I think I'm flying up there on the 3rd. The 4th is Sunday, and I've convinced the current head of the Millstone, not the Millstone, the Westford telescope, which is a VLBI telescope. He has agreed to come in on Sunday and spend 4 or 5 hours with me. We only see each other every 2 years, so he was actually excited that I asked him to come in on a Sunday. But then one of the questions I'm going to ask him is, how do you measure surface roughness of your dish? The Westford telescope is also 60 feet. It's a much different F/D, but I'm going to ask him, how do you do that? Because
Can I show something?
Yes.
Yeah.
So this is your green laser, but then a professional one that scans well, it's used to scan buildings basically.
Yes.
And they put it in front of the dish years ago already, and it gives a very detailed map of the whole structure. It's a lot of work to get it then into Python and processed, but you basically can make surface maps from that to get an idea of the roughness. I'm not sure if it gets you to the level that you need. And on your side, I would be surprised if you have such roughness that it would affect reflections back into your focus box. You should not receive anything at all, because the smallest distortions of your surface already wipe you out. But this is basically, this is kind of the picture you're looking for. This is the deviations from the perfect parabola.
Oh, that's great.
And
That's
you actually do see that there are some areas that are not completely on the parabola.
Yeah, yeah, you can really see it. That's lovely work. I
Yeah.
guess, Thomas, would you say that like you could go through and you could calculate all of these factors. That would be fine, and it's good work to do. But an actual measurement of the system noise temperature somehow might be better, just to kind of like if you have the way to measure your system noise temperature, just make a measurement and then
Yeah.
use that. That would probably be better.
Yeah, measuring it is not too hard, but the real problem is there are many factors in that, and you will never be able to distinguish them. And
Right.
that is really hard. You can only estimate them and you can shift between them, but there's always some ambiguity.
Right. Yeah, I think both, it's a both and, it's not an either or. But if there's any way to like do both, like, yes, go ahead and get a scan. You should absolutely get a scan of your dish, like a physical scan, because it will give you the surface roughness and you'll just have it. But also try to get a system noise temperature measurement, and then both are going to help us a lot in figuring out where the edges are. Yeah, thank you, Rick. That's a huge amount of effort, and I know that, but because of this event, that we'll all be able to move forward. And I'm really hoping that over the next time, this time period up until October 2026 seems like a long way away. It's not really. It'll be here before you know it. I'm hoping that we get more sites involved, that we are able to reach out and connect with more citizen science people, more open source people, more amateur radio people, and that we'll also be able to put together a workshop. It would be really nice to have some sort of get together before October 2026, where folks can present their past work, propose their work that they would like to see done. So if there's some site that wants to host this, it would be fantastic. We'd be happy to help organize and support that.
So we have another dish on the East Coast that was not ready. It's having mechanical difficulties. We have 2 dishes in Australia that if we can because they're professional dishes, they have to be scheduled, but we have a year and a half to grab a piece of schedule, and they seemed very interested. So we may expand our interest base, but only if we keep moving forward from here.
Yeah, it takes a long time to organize and to collaborate and to coordinate. So anyway, count us in, and I think the more sites the better, because you can see what happens when you have two results. So between Dwingelo and Stockart, the combined receiving power gives you an even better picture. So you can just see it in it's like that one graph that just shows you the power of collaboration and cooperation. So getting more of that, I think would be fantastic. We'll know a whole lot more. So yeah, thank you everybody. We're a little bit over time, so I want to be sensitive to the time. Is there anything else that we haven't discussed, or any of action items that we can take care of, or anything that we can do to help?
I think you're doing a lot.
No, happy to. This is why we're here. Yeah, thank you very much to everybody that's watching this recording that is here today. We definitely appreciate you very much. We know that time once you spend it is gone, so your time and your effort is priceless. And thank you so much. It's been a huge
If
week.
anybody is interested in a site tour of the DSES science site, let me know.
Okay.
We don't have to wait for the next open house.
No, you don't. And you guys do have regular open houses.
That's to be debated.
Maybe irregular open houses, but you do have events at the site.
We have been trying to hold an annual open house in early fall. We've been losing money doing that. And there's some concern that maybe we should only do the public open house every 2 years instead of every 1 year. And I don't like that idea, but you don't have to wait for an open house. Just let me know, or let anyone at DSES know you'd like to see the site. We have work crews going out there every week.
Cool. Okay. Yeah, we'll spread around the contact information to make sure that folks know that they're welcome to come actually see it. And I know that that Dwingelo is open to site visits and to having folks visit there too. So we would like to just make sure that folks know that these places exist and they are open and want to hear from you. So we will do the best that we can to spread the word. All right, everybody. We'll see you next week on and this is a regular call. So we're here to talk about stuff. We'll be keeping up the work on this link budget and to making sure that folks know how to get involved and how to support it. And we'll see you on Slack and the mailing lists. And have a wonderful week, everybody.
Thank you.
You bet.
See you next time.